Physics Media, Snell's Law. Refraction is the bending of light as it travels from one material into another. In our experiment, we will be observing refraction from air into gelatin. There are some common examples of refraction, including rainbows and objects as they appear in water. Snell's law is used to describe refraction. It shows when a ray is transmitted into a material with a higher index of refraction, it bends to a smaller angle, and when a ray is transmitted into a material with a lower index of refraction, it has a larger angle. We will be using gelatin, a protractor, laser pointer, and petri dishes to measure the angle of refraction of an increasing density of gelatin using a constant of 1 cup water per trial and increasing gelatin using 2, 4, and 6 packets. We will then use the following equations after gathering our data. We expect that with the increasing density of the medium, the higher the index of refraction and thus a smaller angle and speed of light. After making our mixtures, we note that with the increase of gelatin, there is a gradual change in color indicating the increase in density. We used an angle of incidence of 90 degrees and pointed the laser through each mixture to find the angle of refraction for each one. Our angle of refraction for mixture A, which used 2 packets of gelatin, was 85 degrees. Angle of refraction for mixture B, which used 4 packets of gelatin, was 81 degrees. Our angle of refraction for mixture C, which used 6 packets of gelatin, was 76 degrees. We noted that with the increase of density, it was more difficult to see the laser. We created a chart and used this data to calculate the index of refraction and speed of light from each mixture compared to air. As the chart shows, with increased density of each mixture, there was an increase in the index of refraction and decrease in the speed of light. Our results effectively demonstrated the application of Snell's law to the relations between angle of refraction and index of refraction. In conclusion, in a material with a higher density, we observe a higher index of refraction, a smaller angle of refraction, and a slower speed of light. This experiment was conducted following CDC guidelines to avoid the spread of COVID-19.